All right, well, welcome back. So we're going to continue off from yesterday's lesson, which was finding and applying the maximum and minimum of a quadratic relation. And we had to do this by putting together some form of relation in the first place, some form of equation. Then we took that equation and then we used the completing the square strategy to actually put it into vertex form. And the whole point of doing that was so we could find a maximum or minimum, the HK of the vertex form. That maximum or minimum had meaning in yesterday's or last lesson. It's going to have new meaning, but still the same strategy in today's lesson. So today is the last lesson of the first portion of the first half of Unit 6. After this, you'll have an assessment or quiz, and that will hopefully put everything together. And then we'll move on to more application and more knowledge for this task. So let's start off with two new types of problems today. The first type is something called number problems, and this is the idea of something that we saw earlier in the semester. Where we had to create a system of equations, and we used that system of equations to solve for unknowns. We're going to do the same thing today, and it's going to be the same idea. You're going to create a system of equations. There's going to be some substitutions from one equation into the other equation, and we're going to end up with an end result. The idea, of course, is always getting to that maximum or minimum so we can solve whatever problem is at hand. So let's start off with the first type of problems, number problems. So number problems, as opposed to the area and geometry problems we're going to solve, are just simple descriptions of a collection of numbers and properties that relate between those numbers. So for this first one, find two numbers whose sum is 41. Remember what sum means. Sum is the addition, right? So the sum is 40. So 40. I don't know why I said 41, maybe because of the band. Anyways. And their product is a maximum. Okay, so as soon as we see that word maximum, we know that we're going to have to get vertex form at some point. So let's start off by trying to create our system of equations right after we've defined what our unknown values are. In this case, we're trying to find two numbers. We don't know anything about those numbers other than there's a sum of them and there's a product of them. We don't know how they relate in any way other than those properties. So we're just going to create a simple let statement. And let's say, let x be the first number. And we'll let y be the second number. We don't know anything how they relate in terms of which number is bigger than the other. They could even be the same number. We don't know. So that's why I'm just saying let x be the first number and let y be the second number. That's going to change in future questions, but for now, that's about as much as we got. So the first thing we want to do is we want to try and come up with a system of equations, and we'll do that by looking at the description. We can see here the first description we get is that the sum of these two numbers, the sum, the addition, so x plus y is going to be equal to 40. That's a pretty handy thing to have. Now, if you remember in back a few units ago, we can't really do anything with that number unless we can isolate for one of the variables. So the easiest variable to isolate for here would probably be the y. So all we're going to do is we're going to subtract x from both sides, and we're going to end up with y is equal to 40 minus x. There's our first equation. Awesome. Now let's go over and see what other equation we can come up with. What do we got here? So we got a product is a maximum. That's not super helpful. We know it's a maximum, but we have no idea what its value is. At least with the sum, we were given the value. Here, we just know they're a product. So let's write P for product. And we know what product means. Product means multiplication. So that means that our product is just x times y. I can't really do much with that. However, if you look just to the left here, we actually have a value for y, 40 minus x. So let's do what we used to do. Substitute. We're going to substitute 1 into 2. So that just looks like, so our product is going to be equal to x times our value for y, which is 40 minus x. Now this still doesn't help us find a maximum, or does it? Let's try expanding this and see what we come up with. So if I multiply this x through, what I end up with is 40x minus x squared. This looks like something more familiar for what we've been doing this unit. I see a quadratic value here. So let's rearrange this. to make sure our highest order term, our x squared, is first. So we have negative x squared plus 40x. Now, normally we're used to having a trinomial. We only have a binomial this time, but we can still complete the square. We can still complete the square and put this in vertex form. The only difference is that we don't have some plus value sitting outside our brackets when we start. That's okay. We'll get one eventually because we have to take something outside from inside the brackets. So let's start off by factoring out our entire a term, which is simply a negative 1. So that means I have negative 1 multiplied by x squared. 40 divided by negative 1 means that's negative 40x. And great. But now I got to do the next step of completing the square. Now, if you remember what this is, I write out everything, minus 40x. Now I have to take half of that term. So half of 40 is 20. And I'm going to square that. And then, so that's half of 40 is 20 squared is 400. I'm going to both add and subtract it. Plus 400, minus 400. Great. Now we're not quite done yet. Now we got to bring this minus 400 out of the brackets. But in order to do that, I have to multiply it by a, which is a negative 1. So I still have my brackets as I had before. So p is equal to negative 1 times x squared minus 40x plus 400. And then on the outside, I have my minus 400 times minus 1, so that's plus 400. Okay. Now I have a perfect square trinomial that I can factor. So I have negative 1 times x minus 20, all squared, plus 400. Well, there we go. We now have a vertex. So our vertex is 20, 400. What do these numbers actually represent? Well, the 20 is the value of x. Great. We found our first term. The whole point of this question was find two numbers. We found one of them. We found the first one. Is 400 the second one? No. 400 is the maximum product. This is the maximum product when x is, which is when x is 20. So this is the maximum product. So we found the maximum product in the value of x, but we still need y. So if we have x is equal to 20, how do we find y? How did we always do this when we had previous problems with systems of equations? We would just substitute our known value into one of our previous equations. So let's sub x equals 20 into, let's put it into number 1. That seems like the easiest equation to work with. So that means we have y is equal to 40 minus x, which is equal to 40 minus 20. That means y is equal to 20. Oh, they're both equal to 20. This is just a coincidence, ladies and gentlemen. All right, so now we need our therefore statement. This question is asking us for the two numbers. So therefore, the two numbers are 20 and 20. Great. That's the whole problem. Now, all of these number problems are going to be basically the same idea. The trick is to be able to make the initial equations the first time through. So let's look at the next one. Find two numbers. Okay. They differ. Oh, differ. Differ means difference, which means subtraction. They differ by 16. So the difference of the two numbers is 16. And they have a minimum product. Okay. Find the numbers and the minimum product. Well, that's basically the exact same work we did in the last question. We found all three of those values in the last question. So let's do our work. First of all, we need our let statements. Now, this time, we have to look at the statement and really kind of think about this. We're going to say let x be something, but what is something going to be? Remember, these are two numbers that differ by 16. Now, since they differ, that means they're subtraction, and one of the result is a positive number, that means we're going to have a bigger number and a smaller number. They're not going to be the same number this time, most likely. Anyways, so let's let x be the smaller number. Okay, and we'll say y will be the larger number. Okay. Now what do we got? Now we have to actually create our equations. So we know that they differ by 16. So that means the larger number subtract the smaller number is going to give us 16. So we have y minus x is equal to 16. That's great. Let's isolate for a variable. So now we can say y is equal to 16 plus x. Awesome. We have an equation. What other equation we could do? Oh, we got product again. Same thing as last time. We're going to have equation 2, which is just going to be product is equal to x times y. Now you're probably asking, is it always going to be like that? Nope. Every question is going to be different. Sometimes it's going to be asked for a product. Sometimes it might ask for something different. It depends completely on the scenario that you're given. So just like last time, we're going to substitute our equation 1 into our equation 2. And this is going to give us p is equal to x times our value for y, which is 16 plus x. And now we're going to multiply it through. We're going to FOIL. So that's x times 16, that's 16x. X times x, that's x squared. Okay, let's rearrange. So we end up with x squared plus 16x. We can complete this square. We can create vertex form. Oh, look, there's no a. So we don't have to factor anything out. That means we can skip that step, just put the brackets around, and go immediately to the next step. So that means we have x squared plus 16x. Now half of the second term, that's 8 squared. So it's going to be plus 64 minus 64. Now we want to bring that minus sign to the outside, but the a that it's going to be multiplying by is just a 1. So that actually makes our life nice and easy. So we have p is equal to x squared plus 16x. Oops, I forgot my x down here. Communication. Plus 64. And now we're going to bring the negative 64 to the outside and multiply it by 1, so it's still negative 64. Okay. Now we have a perfect square trinomial inside, so we can factor that. That's going to be x plus 8 all squared minus 64. What does this tell us? It tells us that the vertex is at negative 8, negative 64. What does that mean? It means that our x term is equal to negative 8. We have our first value. It also tells us that our minimum is equal to negative 64. We have 2/3 of all the answers we need. The only thing we need now is to find the y. So we're going to sub x into equation 1. And what do we end up with? Y is equal to 16 minus negative 8. Is that right? Oh, 16 plus negative 8. There we go. 16 plus negative 8, which is going to give us y is equal to 8. I know they look like the same number, but they're not. One is a positive, one is a negative. So we have negative 8 and we have 8. If you look at the numbers here, then we have y minus x. So 8 minus negative 8, that's the same as 8 plus 8. That gives us 16. Perfect. If we look at the product, 8 times negative 8, that gives us negative 64. Awesome. So all of our math works. We just need a concluding statement. So therefore, the two numbers are negative 8 and 8 with a minimum, oops. Oh, I don't know what's up with that giant eraser there, but whatever. With a minimum of negative 64. So those are number problems. Now the next set of problems, they're going to look much different, but in essence, they're going to boil down to the same as the number problems. It's just going to take an extra step to get there first. But all these numbers are basically the same, or all these problems are basically the same idea. So let's go to this next one. So we have a rectangular garden. Let me pause for a second. For all of these area and geometry problems, my biggest recommendation is to start off by drawing a picture. Because as soon as you understand what everything looks like, it's going to make everything else go really, really easy. So let's draw a picture. We have a rectangular garden. Okay, so it's a rectangle. So let's do this. It's a rectangle. Okay. And it is formed by using 220 meters of fencing. So remember, fencing is going to go around. What does that mean? Around a rectangle? That's the perimeter. So we know that the perimeter is equal to 220 meters. Awesome. What are the dimensions of the garden with the maximum area? So if we think about this, this is just a regular rectangle. So let's keep our let statements as simple as possible. Let's say let W be the width and L be the length of the rectangle. Let's say of the garden. Keep it, relate it back to the problem. Okay, so that means that let's say the long edges are the length, and let's say the short edges here are the width. So what does that tell us? We do know that it has a maximum area. It's got a maximum area. Well, what is area? Area is length times width. Great. What else do we know? We know the perimeter is 220 meters. Does that help me? Well, it does, because I know how to calculate the perimeter of a rectangle. The perimeter of a rectangle is just the sum of all four sides. And I got two widths and I got two lengths. So what does that mean? It means that my perimeter, yes, it's equal to 220. And let's do it over here. My perimeter is equal to length. How many lengths? Two lengths. So let's undo that just for a second. Let's go back. My perimeter is equal to two lengths plus two widths. And I happen to know the value of perimeter. So that's 220 is equal to two lengths plus two widths. Well, I can clearly see that I can divide 2 by both sides. So let's reduce this whole equation to 110 is equal to length plus width. That's super great. This is very similar to what we did up here. But if you remember what we did up here, we also wanted to isolate for a variable so we could use that later on. So let's isolate this, and let's put the L all on its own. So let's bring the W over to the other side. So we have 110 minus W is equal to L. Now, I don't know about you, but I like to have my variable, my unknown variable, on the left-hand side. So I'm going to rewrite it one more time. I'm going to say L is equal to 110 minus W. I just flip the equal sign. It's the exact same thing. So this is going to be my equation number 1. So it took us a few steps, but we got to the same place we started with before. What else do we know? We know that it has a maximum area. Well, we also happen to know the equation for the area of a rectangle. Area of a rectangle is just equal to length times width. Okay, so I can substitute into that. So this is going to be my equation 2. And just like before, I'm going to substitute equation 1 into equation 2. So I have area is equal to my length, which is 110 minus W times W. You notice where we are? We are at the exact same location, fully now at the beginning of all of the previous problems. So now we just follow the exact same steps we did before. We're going to FOIL our question out. We're going to then use vertex form, or put it into vertex form by completing the square. That'll give us our vertex, and then we'll have all the information we need. So let's go through this. So let's multiply it through. So that means 110 times W is 110W minus W squared. We have to rewrite this, so our highest order is first, so negative W squared plus 110W. And now we need to complete the square. So I got to factor out my A term. Got to get rid of that negative 1. And then on side, I have W squared minus 110W. Okay, go to the next step. We leave the negative 1 outside. We still have our W squared minus our 110W. Now we got to take half of 110. That's 55. Okay. And then we got to square that. Now you can pull out your calculator, and when you do, you're going to realize that this is a value of 3,025. We need to add and we need to subtract that. Oops. I did 3,024. There we go. 3,025. Okay, we got to get that minus 3025 to the outside. So that means we're going to have to multiply it by the minus 1. So this is equal to negative w squared minus 110w plus 3025. And on the outside, we also have plus 3025 because the negatives cancel each other out. And now we got a perfect square trinomial. Negative, we got w minus 55 squared plus 3025. What does that tell me? It tells me my vertex. You know what? Let's do this up here. This tells me my vertex is located at 55, comma 3025. What does this information mean? Well, the 55 is our w. W equals 55. What's the 3025? That is our maximum area. 3025 meters squared. But we still need to find our length. So we're going to take our w, we're going to substitute it into equation 1 to find our length. Sub w into equation 1. So we have L is equal to 110 minus w, which is equal to 110 minus 55, which is equal to 55. What's that tell us? It tells us that our garden here is a perfect square, 55 wide by 55 long. So let's answer the question. What are the dimensions of the garden with the maximum area? Therefore, the maximum area gardens dimensions are, now I could say the width and the length separately, but they're both the same thing. So I'm going to say 55 and 55. And to be honest, it doesn't really matter which one's the length and which one's the width because it's a rectangle and you can rotate rectangles and you're going to get the same result. So that is our first area and geometry problem. And that's about as simple as that they're going to get. Here's a rectangle, calculate the data that you need. Sometimes we might have to take a little bit of an extra step. So that brings us to example number 4. So in this example, we got a slightly different layout. A rectangular field bounded on one side by a lake. So that means one edge of the field is right up to the lake. So let's pretend that this line here is our lake, okay? We got water going here. Woo! Maybe a fish. It's my beautiful fish, okay? Now there's our lake. Now this is a rectangular field. So we know that it's going to come down like this. There's our rectangular field, okay? A rectangular field bounded on one side by a lake is fenced by 3 sides. There's our 3 sides by 800 meters of fence. So that means there's 800 meters of fence used in total. Obviously, there's no fence on the lake. What dimensions will produce the maximum area? So we have pretty much the same problem as last time, except we have one kink in the road here. And the problem here is that we're not using all 4 sides. That actually makes our life a little bit easier when you think about it. So if we rewrite this and then we label this, let's say these sides are the widths and this long side is the length. So let's say let W be the width and L be the length of the field. So we have our unknowns. Now let's create what equations we can. Well, our perimeter, well, we don't need the whole perimeter this time. We only need partial of the perimeter. Our perimeter is no longer 2 widths times 2 length, or 2 widths plus 2 lengths, because we only need 1 length. So our perimeter is actually just going to be equal to 2 widths plus 1 length. Now we know how much fencing that is. That's 800 meters. So we can write that in. We have 800 is equal to 2W plus L. Now the easiest thing to do here would be to isolate L. So let's do that. So we have 800 minus 2w is equal to L, but let's rewrite it so L is on the left-hand side. So L is equal to 800 minus 2w. This is going to be our equation number 1. Great. So it didn't take us too much work, but we did get to the equation. What's next? Well, we do know that it has a maximum area. It says so in the question. So that means equation number 2 is going to be area is equal to length times width. Wait, you're like, but don't we have to change it because of this? No, because the area is the actual field itself, and it doesn't care that there's a lake to the side of it. It's not like the lake is on top of the field at all. So the area is still the area. We don't know the values, but we do have something that we can substitute in. So we are going to substitute 1 into 2, just like we did in the previous questions. So we have area is equal to our length, which is 800 minus 2w. And we're going to multiply that by w. Now we expand, just like before. 800 times w is 800w. And then minus 2w times w is minus 2w squared. We're going to reorder this. So we have minus 2w squared plus 800. And now we're going to factor out a, which is negative 2. Oh, 800w, sorry. So we have negative 2, and over here we're just going to have w squared minus 400w. Okay, next step, we got to use that second term. So we have negative 2 times w squared minus 400w. Now we're going to take half of the 400, that's 200. And then we're going to square that. Oh, that's a big number. That's 40,000. So we're going to add 40,000. And we're going to subtract 40,000. It's a big field. And now we got to get that minus 40,000 out of there by multiplying it by minus 2. So we end up with minus 2 times w squared minus 400w plus 40,000. And then on the outside, we have minus 40,000 times minus 2, which gives us plus 80,000. Okay. Whew, almost there. We have our negative 2. We have a perfect square trinomial here. So that's going to be multiplied by w minus square root of 40,000, which is 400. 400? 200. 200. Minus 200 squared plus 80,000. All right, what does that mean? It means that our vertex is located at 200, 80,000. Now, what do these values represent? Well, the 80,000 tells us that our max area is equal to 80,000. What is this 200? We look over here. Oh, it's with the w. So this represents our width. So this tells us that our width is equal to 200. So we have 2 of our 3 values. The question is asking what dimensions will produce the maximum area. Didn't actually ask for the maximum area, but we have it just in case there's a follow-up question. There isn't this time, but there could be later. So we got to find our length. So we're going to sub w into 1, and we're going to find that length. Length is equal to 800 minus 2 times our w, which is 200. So length is equal to 800 minus 400, which is 400. So our final concluding statement, therefore, the length of the field is 400 meters, and the width is 200 meters. There we go. That's the whole thing. Example number 5. So this is just another more elaborate version of the same question, but at the end of the day, it's still just the same question. It's going to boil down to the same strategy. So in this case, we have 2 rectangular pens. We can see them over here of the same dimension, and they're built side by side using 240 meters of fencing. What dimensions of each pen, careful, what dimensions of each pen will produce the maximum area? So what does that mean? It means we need to know the dimensions of a pen. So this is still the same thing that we've always done. Our unknowns are going to be the width and the length of the pens. Now we can see that these pens, they're two rectangular pens of the same dimension. So they have the exact same size. Well, that's good news. So we don't have to struggle too much on this. We're going to say let W be the width of each pen. And L be the length. So that means we can draw this. Let's say this is L, 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 W, 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 W. Okay. Whew. Now we know that combined, it used up 240 meters of fencing. So we can write our equation here the same way that we've always done this. So that means we have 240 is equal to, how many L's and W's do we have? We have 3 L's and 4 W's. 3 lengths plus 4 W's, 4 widths. Can we simplify this in any way? No, not really. There's no common thing that we can divide everything out by, so we just kind of have to isolate the hard way. Which one should we keep here? Should we keep L or should we keep W? We've been using L this entire time, so why rock the boat? So let's bring our 4W to the other side. So that means we're going to have 240 minus 4W is equal to 3L. Now I got to get rid of this 3, so that means I have to divide everything on the other side by 3. So 240 divided by 3, that's 80. 4 divided by 3, that's 4/3. And that's going to be equal to L. So I'm going to rewrite this just so I can have my L on the left-hand side like I normally like it. So this is going to be equation number 1. L is equal to 80 minus 4/3 W. Okay, so there's my first equation. What else do I know? Well, I also know that they produce a maximum area. Okay, but remember, each one of these dimensions is for a single pen. So that means the total area is the length times 2W. The area of this entire rectangle is actually 2W times L. So we got to keep that in mind. So equation number 2 is equal to 2W. Whoops, I should probably write that a little bit better. Let's try this again. Area is equal to, let's say, 2W times L. Okay. What can we do now? We can substitute. We can bring our ridiculous L that's on the left-hand side here and put it into the right-hand side. So let's do that. So we have our area, which we don't know what the value is, equals 2 times our W, which we don't know what it is, but we do have a value for L. Let's put that in there. 80 minus 4/3 W. All right, guess what we got to do? We got to FOIL. So 80 times 2W times 80, that's going to give us 160W. Okay. Now 2W times 4/3 W, that's going to be 2 times 4, which is 8. 8/3. W times W gives me W squared. Not the friendliest of terms, but it's not incorrect. So let's rearrange this. So we have negative 8/3W squared plus 160W. Now we have to factor out, believe it or not, we got to factor out this entire A term. We got to factor out negative 8/3. So negative 8/3, and that's going to be W squared. Now we have to divide 160 by 8/3. Now some of you may be able to do that in your head, but probably not. 160 divided by 8/3, negative I should say, but so what does that actually mean? That means the same thing as 160 times 3/8, negative. So if we do this, 160 times 3, that's 300, that's 480, yeah, equals negative 480 over 8, which is just negative 60. Okay, so we can put that in there. So that plus sign is actually wrong. And I'm going to make my square look a little bit better, like a square here. So you are going to be a square. And now we have minus 60. W. Don't get rid of your W. Okay, the beat goes on. We're not done yet. We got to keep going. We haven't finished our completing the square yet. We're not complete. So our negative 8/3, our area is equal to negative 8 over 3. Is still out there on the outside. Inside we have our W squared minus 60W. Now we have to take half of the 60, it's just 30, squared is going to give us 900. So plus 900 minus 900. And now we're going to bring that minus 900 out to the outside. So that's going to be negative 8 over 3 times W squared minus 60W plus 900. Now on the outside we have 900, negative 900 times negative 8/3. So negative 900 multiplied by negative 8/3. This can cancel out and bring this down to 300. So that means that we have negative 300 times negative 8. That give us a positive 2400. I think that's right, 2400. Yeah, it is. So this is going to be plus 2400. And now we got to finish. We have a perfect square trinomial inside, so we have negative 8/3. And then inside we have W minus, what was that? 30? Yeah, 30. The square root of 900 is 30 squared. And then we have our plus 2400 on the outside. So we have our vertex. Our vertex is at 30, comma 2400. So what does this actually represent? This tells us that our width is equal to 30. This tells us our maximum area is 2400. Now what is the question asking us? The question is asking us for the dimensions that will produce it. So we still have to find our length. That's our W. So we got to sub W into 1. So we have L is equal to 80 times negative 4/3 times 30. This is going to cancel out and this is going to become a 10. So now we have 80 minus 40. So L is just going to be equal to 40. There we go. That's all of our stuff. So now we just need to give our concluding statement. Therefore, the dimensions of the pens, of each pen, this is the important part, each pen, the dimensions of each pen are 30 wide and 40 long. 30 meters wide and 40 meters long. Don't forget your units. Okay, we have one last question left, and we're going to get away from rectangles for a second because it doesn't always have to be rectangles. We have to be able to think outside the box. It could be circles, could be hexagons, could be anything. In this case, this next one is going to be triangles. Okay, so this one says the sum of the base and height of a triangle is 24 centimeters. Determine the maximum area of the triangle. We have no idea what this triangle looks like. We don't know what type of triangle it is. We just know it's a triangle. And it tells us that the sum of the base and the height is going to be 24 centimeters. So let's draw a picture first of all. So imagine this is my triangle. Okay. And my height goes down there. And my base is this entire area down here. There's my base. Okay, so let's keep it simple. Let's say let B be the base and H be the height of the triangle. Okay, so now we got to do the same thing we've always done. We got to start creating equations. And the first one is the obvious one. The sum of the base and the height of a triangle is 24 centimeters. Okay, so that means base plus height is equal to 24. So let's isolate for one of these. Let's isolate for the h, I guess. So h is equal to 24 minus b. So there's our equation 1. The height is equal to 24 minus the base. Okay, what else do we know? Well, we know the area. What is the area? Well, what is the area of a triangle? The area of a triangle is 1/2 times base times height. Now, a lot of people write this in a lot of different ways. Sometimes they'll write the area of a triangle as base times height divided by 2. But that's still the same thing as saying 1/2 times base times height. It's the exact same equation. We're going to write it like this because it'll help us. We're going to write it in this fashion because it'll help us with our calculations later on. Just because 1/2 becomes a multiplier instead of a divider. It just makes life a little bit easier. So our area, let's say equation number 2, our area is equal to 1/2 times base times height. So look, we're basically at the same questions as we've been doing the whole time before. We just got to substitute and do the work the same way we've been doing so far. So let's substitute 1 into 2. So our area is equal to 1/2 times our base. Oops, that was supposed to be a b. 1/2 times our base times our height. Well, what is our height? Our height is 24 minus b. So what do? We FOIL. So 1/2 b times 24. So that's 12b. Minus 1/2 b times b. So minus 1/2 b squared. Okay. We do the same thing we've always done. We're going to complete the square. So we need to rearrange this first of all. So equals negative 1/2 b squared plus 12b. And now we got to factor out our a term, which is negative 1/2. Negative 1/2. And we got b squared. Now 12 divided by a half is the same thing as multiplying it by 2. So that's minus 24b. And now we have to follow the next step. Okay, negative 1/2 b squared minus 24b. Now we need half of the second term, so that's 12 squared is 144. Plus 144 minus 144. And now we got to bring the 144 outside, the negative 144 outside. So we have equals negative 1/2 b squared minus 24b plus 144. So far, so good. And now we have minus 144 times a half. So 144 divided by 2 is 72. So the minuses cancel out, so we just get plus 72. All right. Can we finish it? No, let's bring it up here. Just to give us some space here. So we have area is equal to, we still have our negative 1/2. Now inside the brackets, we have a perfect square trinomial. So that's b minus 12, 144, the square root of 144 is 12, squared. And now we're going to add on our 72. So now we have our vertex. Our vertex is at 12, 72. What does this actually mean? The 12 is our base. I guess I shouldn't have written that whole thing. Base is equal to 12. And the 72 is our maximum area. Okay. This is actually just trying to calculate. This thing only asked us to find the maximum area of the triangle. It didn't actually ask us to find the height. So we could end the question right here. We could say, therefore, the maximum area of the triangle is 72 centimeters squared. Great. Now, if you had a follow-up question, chances are the next follow-up question would be, hey, what is the height of your triangle? In which case we would sub b into equation number 1, and we'd end up with height is equal to 24 minus b. So height is equal to 12. Oh, look at that. They're both equal to 12. Okay? And that would be our triangle. but that's not what the question asks. Anyways, so that's it for our first half of Unit 6. We really only learned one thing in this entire unit, which was how to complete the square. That's it. Everything else was just an application of these things. Just remember, for each one of these steps, we have to create a problem. We have to create the equations. Once we have the equations, we might have to expand, or we might have an equation that's already in standard form. Once we have that, our next job is to complete the square. Once we've completed the square, we now have vertex form. Now that we have vertex form, that means we have our vertex, our HK, our maximum or minimum value, and whatever value gets us there. Okay? And that is the entire setup for the whole unit. If you got that down, you're going to be good to go. Good luck. I'll see you in class.